Okay, this is a quick little video using Kim Libre again to just go over reaction rates. And so uh, the main idea here is building up to the rate law. And so this is a nice little graphic showing that if we start and then with all these are reactants, and we go to the product, that we get this change in the number of molecules, but often it's actually concentration that we want. So either concentration for solutions or pressure for gases. And so they're going to continue to vary through the course of the time. And so what we want to get out is a rate expression. And so the rate, the reaction rate, is going to follow then the change in concentration. And so we have this simple little ratio. It's kind of a little annoying how they build up because it's 1 to 1, but it's showing the first step is that if we look at reactants, the concentration's going down, so the change in concentration. So we want all these to be equal, so we make this one negative, so that way we get a positive reaction rate at the end. You have to scroll all the way down to the bottom in order. There's a couple of examples about calculating that change in concentration, change in time. Very simple. And the main thing is then we start to look at that effect of the coefficients. And so we get this kind of inverse relationship. You can get the same thing by just thinking about concentration and using stoichiometry, but it's best to do it this way so that way you can always relate it to the rate. So finally down here, example 13.2, now we can see a reaction where we get all these different coefficients, and it'll walk you through the process of relating them. And it's just the inverse of the concentration. Okay, that's it. A couple of simple calculations, and then we'll get into the rate law then.